Warm greetings to everyone. We are here to present our work titled Design and Implementation of Deep Learning Based Illicit Drug Supplier Detection System at the Third International Conference on Data Science, Machine Learning and Applications. We would like to thank the management for giving us this opportunity. The agenda of our presentation is as follows. So we begin with comparison between the existing system and the proposed system, the objectives which were identified from the literature survey, an overview of the drug distributor detection system using CNN, the design of the convolutional neural network which was used to implement this design, the performance of the neural net, uh, named as logging metrics, and the hardware implementation of our system, and finally the results and the discussions followed by the references. So the motivation behind our work is the alarming increase in the usage of illegal substance and drugs, uh, especially among youngsters who are said to be the upcoming generation, the future of our nation, the future of the world. So, as academicians, it becomes our social responsibility to ensure that such a scenario is addressed to with utmost care and in the most efficient manner. So, this is actually the motivation behind our work. We have tried to do the best that is possible. In the existing system, face recognition has already been done using deep learning, using the CNN, but it has not been utilized for such an application as yet. The drug trafficking, it has been identified to be happening at a drastic rate over the social media, but that has been identified with the help of words that are exchanged, or the messages which are exchanged among the drug traffickers or drug users. The specific words which are used in relation to such an interaction has been identified, and then the follow-up happens. But the drawback here is these days people don't directly use the associated words. They speak in code words, and it become every group has its own code word, and it becomes difficult to decode it. So we have thought of an image related system wherein videos would be captured and compared with the database which is already available in the criminal records right now, and identify the drug users and protect our children. So the objectives is as follows. Our objective is to develop a CNN algorithm. Why we choose CNN is because it is computationally less complex, and it can process maximum number of faces with minimum number of false alarms. Next is to classify the authorized students and the drug distributors within an area, and to train the CNN network to reach the maximum accuracy, and also to implement this entire system on a hardware in real time. The overview of our system is as follows. So we begin with image acquisition. The image is acquired from videos. It is captured from videos. Then the faces of the people in that frame is identified and detected. It is then pre-processed. The features of the face, specifically the face area, is extracted, and the face recognition is done wherein it is compared with the existing database. This is where the CNN comes into the picture, and if it is identified to be that of a drug supplier, then an alert message or an alarm is sent to the management for further actions. So this is the block diagram of our work. The input is in the form of video frames, which is then subjected to Haar cascade classification, wherein the face is detected, followed by pre-processing. So the output of the Haar classifier is usually an image in the RGB format. It is converted into grayscale in the pre-processing stage. It is then provided to the CNN. In the CNN, feature is extracted from the hidden layer. The convolution layer forms the basis of the CNN, wherein the firing of the neurons takes place. The output of this is given to the rectifier linear unit, wherein the activation functions are applied, and the output is collected in the pooling layer, and it is carried forward to the next stage from the connected layer. The next stage of feature extraction which is used, this is basically to extract the feature from the validation set or the outliers which come in as inputs, and that is compared with the database or the data which is available for which the network is trained. After the comparison, the classification is done, as in we obtain the result of whether the face detected is that of an authorized student or that of a drug supplier. If it is of a drug supplier, then an alarm message is sent to the management. These are the design parameters which were used to design our CNN. These parameters and how we arrived at these parameters have been discussed in depth in the manuscript. And this is the flow diagram which has already been discussed of the entire CNN process. These are the performance characteristics of the CNN. So initially we look at the classifier accuracy. So we have obtained it for 5 epochs. We've trained the CNN module for 5 epochs and obtained an accuracy of about 99.8% for the training set and 99.5% for the validation set. We've also obtained the classifier loss as 0.22 for the training set and 0.79 for the validation set. This is an image of the hardware implementation of our proposed system. We have used Raspberry Pi 3, and we have used the Pi camera in order to capture the videos from which the image of the person to be identified is extracted and processed. This has been done entirely on using the laptop. So we have used the VNC software installed in the laptop to do this. And the unauthorized message, if an unauthorized person is identified, the alarm message would be sent by the laptop itself. So these are the results which were obtained. So the Pi camera basically captures 30 images of a particular individual, and the faces of these individuals are detected and converted into images stored in the form of pixels, a matrix of pixels, and each of it will have its own respective ID. And here we have considered face samples of 5 students and 3 drug dealers, of which this is the face sample of a student. Similarly, this set is also the face sample of a student, whereas this set is the face sample of a drug dealer in different angles, obtained in different angles as covered by the 30 images captured by the Pi camera. The training of the recognizer is basically in the form of extraction of features. It is stored in the form of a YML file. As you can see, it would be in the form of certain values. Either it would be a 0 or some values. This is basically to store this in the form of a database for offline processing. So every image can be stored in this format like values and used for offline processing. Finally, here we have captured, we took a 2-second video, which is a very general enacted video only, but that is what we took as a sample, and we provided it to our system, wherein this basically shows the classification or puts the label to the different faces it detects. For example, this is the face of a student 1, this is the face of student 2, whereas this is identified as the face of a drug dealer, and the drug dealer ID is also provided. So once this drug dealer's face is identified, the management receives a message, and this is done using the Twilio API. So this is the video snippet which we considered. As you can see, this is in different scenarios. The first one shows a different scenario. The second one shows a different scenario where the drug dealer is present. But the face recognized happens with great accuracy. So once it is recognized, the Twilio app is used to send the alert message. So on a concluding note, this work successfully presents the software simulation of the drug distributor detection system. It is based on CNN algorithm using the OpenCV and the Keras with TensorFlow backend, which is an application for face recognition system. And in order to implement this system on hardware, we have used the Raspberry Pi 3 and a Pi camera module. And the combination of hardware and the software which we have used has brought down the computational cost of our system and improved its effectiveness, and also brought down the computational complexity of the system. CNN algorithm is absolutely accurate in terms of identifying the face and reducing the number of false alarms. Uh, So these are the references which have been referred to in order to implement our work. As a future scope, we would like to deploy this as a standalone work wherein it may not depend upon the already existing database in order to recognize any malicious activity which takes place in case of drug, related to drug trafficking or any other surveillance application as such. Thank you for giving us this opportunity. Thank you.